Okay. Check. Sound. Good. Okay. All right, we're going to continue here, and we're saying that this is going to be a partial fraction one, right? So let's look at our partial fractions. 2 over x minus 2, I'm sure that's not a shock. That's equal to a over x minus 2 plus b over x. If you're asking if you have to write it in this order, the answer is no, as long as you keep your coefficients straight. Okay. So 2 equals x times a plus x minus 2b. If x is equal to 2, we get 2 equals 2a, so a equals 1. If x equals 0, we get 2 equals negative 2b, so b should be negative 1. So that means the integral, or the antiderivative of 2 over x squared minus 2x dx is equal to antiderivative of 1 over x minus 2 minus 1 over x dx. Okay, let's integrate each part. This technically is a u substitution. U equals x minus 1, x minus 2. Du equals dx. So this is 1 over u dx. Antiderivative is just a natural log of x minus 2 minus the natural log of the absolute value of x plus constant. There's that. Okay, now that we have the antiderivative, we work on the integral. The limit as b approaches negative. A to negative 2 of 2 over x squared minus 2x dx is equal to the limit as a approaches negative infinity of the natural log of x minus 2 over x from a to negative 2. Plug in. This is a natural log of negative 2 minus 2 over negative 2 minus the limit as a approaches negative infinity of a minus 2 over a. I forgot the natural log. Okay, negative 2 minus 2 divided by negative 2 is 2, right? Natural log of 2 minus, as a goes to infinity, negative infinity, a minus 2 over a goes to 1. No, we have first degree over first degree. 1 over 1 is 1. So this goes to 1. Natural log of 1 is 0. So the integral from negative infinity to negative 2 of 2 over x squared minus 2x dx is equal to the natural log of 2. Antiderivative first, deal with the definite integral later. Okay, let's do the antiderivative of this one first. Let's go down the list. I'm pretty sure the first few don't work. And I'm all the way down to either integral by parts or partial fractions. Integral by parts, right? And if I'm doing integral by parts, this looks like a good one to use a chart method, right? Sorry, tabular method. So yay, tabular method will save us all. X e to the 2x, 1, 1/2 e to the 2x, 0, 1/4 e to the 2x. So this is equal to 1/2, everything has an e to the 2x. So 1/2 x minus 1/4. Actually, you can factor out that 1/4. 1/4 e to the 2x, 2x minus 1. That looks nicer. Okay, so now we can deal with the limits. We got negative infinity, so limit as a approaches negative infinity from a to 0 of x e to the 2x dx. That's equal to the limit as a approaches negative infinity of 1/4 e to the 2x, 2x minus 1 from a to 0. Much nicer when you have the antiderivative. Yeah?
Can you just move up?
Yeah, I can. I should have given you a pause there. Okay. Let's plug in. This equals 1/4 e to the 0, 0 minus 1, minus the limit as a approaches negative infinity, 1/4 e to the 2a, 2a minus 1. This is equal to negative 1/4 minus the limit as a approaches negative infinity. Now, I'm not sure what to do with this. What happens here? We have infinity. No, we're going to negative infinity, right? Yeah. So e to the negative infinity goes to 0. This goes to 0. This goes to negative infinity. Okay, so we need to turn this into a L'Hopital form. Do you want to put this to the denominator or this one to the denominator? What do you think? I think the e is easier on the denominator, don't you think? I think the e is easier on the denominator. This is 2a minus 1 over 4e to the negative 2a. Okay. Let's check this form. This is infinity over infinity. Right? We have a is going to a large negative number. Large negative number times negative 2 is a large positive number. E to a large positive number means infinity. So we L'Hopital equals negative 1/4 minus the limit as a approaches negative infinity. Derivative of 2a minus 1? 2. Derivative of 4e to the negative 2a? Negative 8, yeah, I think I had e to the negative 2a. L'Hopital. Negative 2? Okay, now as a goes to negative infinity, where does this go? E to the negative 2a goes to infinity. 2 over a very large number is 0. So this is just negative 1/4. Okay. Give you a minute to get this down. Oh, I'm still on 14, right? Okay. Ready to go? Let's do the antiderivative first. Antiderivative of e to the 1 over x squared dx. Not a basic integral. Can't really simplify to make this easier. Nothing is going to really cancel out. Doesn't look like a Pythagorean form. Oh shoot, I forgot U substitution. Is there a U substitution I can make? Yeah. Typically, when you just U substitution with an exponential, the U is the exponent. So U is equal to 1 over x, making du equal negative 1 over x squared dx, which is very convenient. There's 1 over x squared. There's dx. I don't have this negative, so I'm going to shoot it over to the du. So this antiderivative becomes antiderivative of e to the u times negative du. That antiderivative is just negative e to the u plus constant. Let's take a look at my original function. Which one of these gives me a problem? 0 or log 2?
0.
Yeah, 0 gives me the problem. So I'm going to limit that 0. I've already done the antiderivative.
the test, do we have to say 0 and write 0 and 1?
I would like you to. Okay, I don't have, I'm plugging in natural log of 2 first, so I don't actually need the limit for that. Minus negative. Okay, so as a goes to 0, 1 over a goes to let's try that again. As a goes to 0, 1 over a goes to infinity. Okay. If e gets raised to something that approaches infinity, we get infinity again. We have infinity plus a negative number, still infinity. Diverges. Any constant over 0 approaches infinity. Constant over 0 approaches infinity. Okay. Gosh, I wonder where I got these problems.
How long ago did you get that?
You don't remember these problems?
15's from the book. I remember 15. This one I remember.
This was from the homework, yeah. So let's make quick work of it. Antiderivative time. U is going to be 4 minus r. du equals negative dr. So this becomes negative u to the negative 1/2 du, which is negative 2 root 4 minus r plus constant. The problem here is when we reach 4, the denominator does not exist. So we have to take a limit as b approaches 4 from the left, 0 to b, dr over root 4 minus r. That's equal to the limit as b approaches 4 from the left, negative 2 root 4 minus r from 0 to b. Just think about, we're going from the left side to the right side, or from the left endpoint to the right endpoint. If we're going to this endpoint, we're coming at it from the right side. If we're going this endpoint, we're coming to it from the left side.
Oh, okay.
Okay? Just kind of visualize where that area is. Okay. Substitute. Limit as b approaches 4 from the left, negative 2 times 4 minus b plus 2 times 4 minus 0. If b approaches 4, we can do 4 minus 4. 0. 2 times 0. So negative 0 is still 0. This is 4. And so the integral from 0 to 4 of dr over root 4 minus r is equal to, we said 4, right?
Yeah.
It's 4.
Wait, so like since there is an infinity in plug into B, that means like it would be 0 or something.
Hmm?
I mean, like, since infinity's been plugged in.
We're not plugging in infinity.
4, like that would be 0, right?
Because over here we're going to get a dr over 0. Or 1 over 0. Okay, 16. Let's look at the antiderivative first. That's dx over, can we factor that? X plus 3, x plus 4?
Yeah.
Yes.
It is going to be integral by partial fractions, but just make sure none of the others work. In particular, there's no way I could use a u substitution here, right?
No.
Yeah. So, pretty sure I'm going to be using partial fractions. So we have 1 over x plus 3, x plus 4 equals a over x plus 4 plus b over x plus 3. I should be in blue right now. 1 equals x plus 3a plus x plus 4b, bless you.
Thank you.
Pick a number. Sure. If x is negative 4, then a will be negative 1, I believe. And if x is negative 3, b will be 1. I see I put these in backwards. Okay. Integral of dx over... You okay? Stay composed. X squared. 7x.
Yeah, I get scared really easily. I'm really fun to go to.
I'm going to switch the order, so...
I really don't want to at all. So, I'm probably just going to go to order.
Actually, let's not switch the order. Let's finish this up and then we're going to take our break, okay? Oh, we should actually go to 17. I'm sorry. Let's get to 17 and then we'll take a break, okay? All right, so we got that. We're going to integrate that. This is negative natural log of x plus 4 plus the natural log of x plus 3 plus constant, or just the natural log of x plus 3 over x plus 4.
Oh, no, never mind.
I dealt with the negative.
Because you made it ln x plus 3 minus ln x plus 4.
Yeah, dealt with that negative. Okay, so the hi.
You know Natalie, right?
Yes.
Someone stole her iPad, so we need to check the room, but there's no janitors around, so we were wondering if we could borrow your key.
Which room?
Miss Serena or something?
I don't have a
The building key doesn't work for the, okay.
key. Library key doesn't.
Okay.
You sure not upstairs?
No, the teachers are there.
None of the teachers there? Oh yeah, they leave early.
Yeah.
Okay. All right. Sorry.
Okay.
Try in the other.
The main office, there might be some janitors.
Yeah.
Like, helping
A
us.
building?
Yeah, it's just
Try D building or E building. There's a E building janitor
Yeah,
usually.
there's always someone there.
Yeah. You
Okay,
go.
bye.
Oh, thank you. That really sucks.
You reached your name.
Oh no, it's my fault.
There's someone right here.
Why is it your fault?
Her name was on the board and it was erased. Okay, so we have the limit as b approaches infinity from 1 to b of dx over x squared plus 7x plus 12 equals the limit as b approaches infinity of the natural log x plus 3 over x plus 4 from 1 to b. Plug in. Limit as b goes to infinity. The natural log of b plus 3 over b plus 4 minus the natural log of 1 plus 3 over 1 plus 4. Let's take a look at that natural log. As b goes to infinity, we have a first degree over first degree. 1 over 1, 1. So natural log of 1. So this is equal to negative natural log of 4/5.
Why not?
But to make it positive, you have to.
Yeah. Which equals natural log of 4/5 to the negative 1 power.
We have to do that?
Wait.
Mm-hmm.
If it's b plus 3 over b plus 4, why isn't it infinity over infinity?
It is infinity over infinity.
Don't we need L'Hopital?
Sure. We did.
We did.
Yeah.
When you take the derivative.
Yeah. Wait, thanks.
All right, we're almost done. Natural log of 5 over 4. The reciprocal of 4/5 is 5/4. Okay, last one before break. Or no, let me give you a few minutes to finish up here.
Wait, so will this be diverge or converge?
We got a number, right?
So you don't put diverge or converge?
Converges to natural log of 5/4. That works too.
Doesn't that always happen? The limit just starts getting more legible as you go more deeper into math.
Pretty much. It just becomes a squiggle. Looks like a exaggerated L. Yeah. Okay, let's take a look at this antiderivative. That's a 2, right? Okay, pretty sure it's not a basic one. Pretty sure I can't algebraically simplify this. U substitution. No, that doesn't work. What else can I do? This doesn't look like a Pythagorean form. So I'm down to integral by parts or partial fractions. Integral by parts, good. And this looks like a good tabular method, right? Okay, so we have u dv x squared and e to the negative x, 2x and negative e to the negative x, 2 and e to the negative x, and 0, negative e to the negative x. Plus, minus, plus. Okay. Every term has a e to the negative x, right?
You do negative
E to the negative x. So this leaves me with a negative x squared.
Negative e to negative.
Yeah, because they're all negative.
Would you like me to do that?
Yes, please.
Okay.
Just to not add confusion, to put some positivity in there.
Plus 2x plus 2 plus constant. All right, so we're going to positive infinity, right? So the limit as b approaches positive infinity, 0 to b, x squared e to the negative x dx equals the limit as b approaches infinity of, let's see, x squared plus 2x plus 2 over negative e to the x. Gosh, I think that's going to be a lot easier for us if we do it that way, right? From 0 to b. Okay, let's substitute things in here. The limit as b approaches infinity of b squared plus 2b plus 2 over negative e to the b plus 0 squared plus 2 times 0 plus 2 over e to the 0.
No, because you need plus.
Okay, this is great. Let's talk about this limit.
It's minus.
It's infinity over infinity, is it not? L'Hopital? That's 2b plus 2 over negative e to the b plus 2. Okay, this is still infinity over infinity, right? Let's L'Hopital again. This is 2 over negative e to the b plus 2. This is no longer indeterminate. As b approaches infinity, e to the b approaches infinity, we have 2 over a very large number, which is 0. All of that for 2.
It's like when you had algebra 2 and you